Okay, I'm given a polynomial here. It's not written in standard form because it doesn't go from left to right from the highest exponent to the lowest. So in order to write it in standard form, that's what I need to do. So I'm going to go ahead and write f of x equals, look for the highest exponent. The term with the highest exponent is 2x to the 10th. The next highest one is minus 10x to the 7th. Don't forget to carry with it the leading plus or negative sign. Then what do we have left? Plus 5x to the 4th. Got that one. Plus 6x cubed. Minus 8x. And the constant at the end. So that is how we write the polynomial in standard form. Next, we are asked to state what is the degree of the polynomial. Well, once we have the polynomial in standard form, it is easy to find that the degree is the highest exponent. Here, that degree is 10. What's the leading coefficient? Well, what is that coefficient out front of the term with the highest exponent? Here, the leading coefficient is a positive 2. Right? 10 is even, and 2 is positive. Knowing those two facts are going to help us with part E, but first let's look at what is the y-intercept of the polynomial. Well, the y-intercept, we find that by plugging in 0 for x. So f of 0 equals, and I'm just going to plug in 0 for x. I see that every term, if I plug in a 0 for x here, that term becomes 0. Same here. Same with all of the terms with x in them. Those all become 0, and what I'm left with is 12. So the y-intercept, it's a point. We're going to use an ordered pair, 0, 12. And last, part E. Part E, well, we know that the function is even degree and positive leading coefficient. Right? So when that is the case, which end behavior applies? We have 4 different choices here. These are the 4 different end behaviors. We know that these 2 end behaviors are even degree. These 2 are odd. And this is a positive leading coefficient and a negative. So leading coefficient, this is a little graphic organizer. If you guys don't have this down yet, I recommend you writing this in your notes. We've got even degree and positive. So we have even and positive. This is our end behavior. The end behavior of this corresponds to as x goes to the left, y goes positive, and if x goes to the right, y also goes positive infinity. So that is the end behavior.